Good morning, class. Today's topic is geometry, and we're going to be exploring shapes. This unit consists of students identifying attributes of two-dimensional shapes, describing their sides, equal, parallel, or different lengths, and the amount of corners a shape has and its relationship to the amount of sides of a shape. Students will also be identifying their names and classifications, and also describing the similarities and differences between them. Some key knowledge for this lesson is to use specific language for the shapes, like sides, corners, and vertices for the points. And two-dimensional shapes will be classified in accordance to the amount of sides, and also making the students able to differ from similar shapes like squares and triangles. Squares and rectangles and hexagons and octagons. So to begin with the students' prior knowledge from the foundation level, this is a level 1 activity. We assume that the students know basic properties of 2D shapes, some names, and so in this demonstration I plan on advancing that foundation level by asking the students to construct a shape using a geo-board. The first task will simply be to ask the students questions like, what shape has 3 sides? Of course we know it's a triangle, but given their prior knowledge, we can also cater to kinesthetic learners for them actually to do the shape physically. So in this activity I will ask Galen here to make a shape on the geo-board using a rubber band. So Galen, a triangle has 3 sides and 3 corners. Can you please make one? As you can see, he's made a triangle. And then I'd follow this by asking, do triangles have to have 3 equal sides?
No.
No. If the student were to answer yes, which could be a common misconception if they were to do an equal-sided triangle like the one Galen's done, I could also assist them by manipulating this using the rubber band on the geo-board by creating an isosceles triangle. This one here is an equilateral with 3 equal sides all around. So Galen, can you please make an isosceles triangle? As you can see, this one has 2 equal sides and 1 length that is not equal. And then follow this task by asking them what is a scalene, if they know what a scalene triangle is. So if Galen, if you could make a scalene triangle, please. This is in fact a scalene triangle. And then we could also continue this activity by asking them to describe the properties of the triangles and how they differ from each other, yet still being a triangle. This activity can also be done with shapes and rectangles. Some common misconceptions would include the student not making any shapes at all, but taking into consideration the 4 sides and the 4 corners, but in fact making an irregular shape, which is not relevant to level 1. Another great activity for this is a who am I. So I would start the activity with questions like, I am a 4-sided shape, I have 4 corners, I have 2 sets of equal sides, 2 long and 2 short, and the shape is in a classroom door. Of course, from this we can see that it would be, in fact, a rectangle. Um, this activity is great in the sense that it will get the students in higher order thinking of both visually and kinesthetic approaches. It would also make them point out similarities and differences between similar shapes like squares and rectangles, as I've mentioned before. And also, it's a fun and enjoyable way for the students to learn. The learning objectives are for students to develop a greater sense of shapes and how they're formed and their properties. As stated prior, it will give kinesthetic learners a chance to get hands-on with making shapes. Visual learners will be able to see the shape physically in front of them, and auditory learners will remember cues of shapes and their properties and be able to manipulate them in such a way. This activity will also give students the ability to justify why a square is a square and not a rectangle. For example, based on the facts they practice. Thank you.